Hey, greetings and welcome, friends. We're taking a look at 2007 NECAP question number 13. Interesting thing about this problem's worth 1 point on that NECAP test back in the past. So if you ever time travel and you're interested in doing this problem, that's how much it will be worth. But back in the day, Twin Valley students got no points on this. Oh, man, for shame. And also back in the day, Vermont students, only 10% of them got the point. Oh, boy, oh boy. Well, let's take a gander at this, shall we? It says, look at this inequality. So I'm looking at it. And it says the absolute value of x plus 5 is less than or equal to 2. And then it says list all integer values of x that make the inequality true. So integer values are negatives, positives, 0, as long as they don't have, right, decimals or fractions, right? So let's see. If I have the absolute value of x plus 5 is less than or equal to 2, and if I wanted to solve this, well, the absolute value is isolated, and it turns out we can use the break it up technique. Break it up. So I could have x plus 5 is less than or equal to 2. That would be my first inequality that I could gather from that, right? X plus 5 was positive and it's normal. Or I could have that x plus 5 is related to a negative 2, but it turns out it's not going to be less than or equal to that. Or, well, actually, maybe you could think about it this way. The opposite of this was less than or equal to negative 2. Okay, I guess maybe is how I could say that. But I'll create a shortcut later on in today's lesson. So then I could solve either of these, each of these. This negative, I'll distribute there, perhaps. So this says x is less than or equal to, let's see, 2 and 5 are different, so I subtract those numbers, I get 3. The more influential is negative, right, because it's 5. And this one, negative x minus 5, oh please, is less than or equal to negative 2. And we'll do the old plus 5. Wait a minute.
I don't know why you...
This, wait a minute. Yeah, this 2 should have been positive. My bad.
No, that 2 should be negative.
I'll get there in a second. It will be. Don't you fret. If I got rid of this negative sign on both sides.
It works for me.
You
That's
only
all
need the negative on the 2.
Yeah.
You don't need to make the other side negative.
But there's a reason that I did that. I'll have negative x is less than or equal to 7. And in order to get the negative away, I could like multiply or divide both sides by negative 1, right? And you get x with a negative 7. However, due to this one little step here, it turns out you have to flip the inequality, which is what I want to point out. So I end up with x is bigger than or equal to negative 7 or less than or equal to negative 3. All right? Anything between those, exactly. So integers that would make this equation true would be like negative 7, negative 6, negative 5, negative 4, or negative 3, right? Because those are all of the integers that are in between or equal to those two things, inclusive of them. So this is a good little problem. Good little problem right there. I like it a lot. So we'll explain more on this concept of absolute value inequalities a little bit later today. Don't you fret. Thanks for watching. Bye-bye.